Hey, Harsh here. How should your services talk to each other? Before we fight over protocols, we have to understand the battlefield. As we move away from monoliths, which become expensive and risky to scale, we break our systems into distributed nodes. But now these nodes have to talk. It's not just a function call in a memory anymore, it's a network request. This introduces latency, serialization costs, and failure modes. This is where REST and gRPC come in to solve the communication issue. To understand gRPC, we have to understand RPC. It stands for Remote Procedure Call. The goal of RPC is simple. I want to call a function on a server, say get user, exactly like I call the function in my local code. I don't want to know about TCP handshakes or headers. I just want the data. This abstraction, where the network details are hidden behind a stub, is the foundation of what we are discussing today. REST isn't a protocol. It's an architectural style. It treats everything as a resource. If you want a user, that's a resource. If you want an invoice, that's a resource. And we access these resources using standard HTTP methods. The most critical concept here is statelessness. The server forgets you the moment it sends a request. This makes scaling horizontally much easier because any server can handle any request. Most of us think we are building REST APIs, but we are usually stuck at level 2 of Richardson Maturity Model. True REST includes level 3, includes HATEOAS. This is where the API response includes links to other things you can do. If you request an order, the JSON doesn't just give you the ID, it gives you the URL to cancel that order or view the customer. It allows the client to navigate the API without hard coding every URL. If you're building REST, you must follow the conventions. Don't use verbs in your URLs. The HTTP method is the verb. A GET request to /users retrieves them. A POST request to /users creates one. And pay attention to put versus patch. Put replaces the entire resource while patch just changes the fields that you send. Also, version your APIs. Whether you put it in URL or the header, pick a strategy early or you will break your clients. Developed internally at Google, where it was called Stubby, and open sourced in 2015, unlike REST, which is a set of guidelines. gRPC is a framework. It enforces a specific way of doing things. It uses HTTP2 for transport and protocol buffers for data format. It forces you to be contract first. You can just hack together a JSON response. You have to define the structure formally first. In REST, we send JSON. JSON is text. It's heavy. If I send name Alice, I am sending the string name every time. In protobuf, we define a schema. The field name is assigned to the tag 1. When it travels over the wire, it's just binary data representing tag 1. It strips out all the metadata overhead, making payloads significantly smaller and serialization much faster. gRPC isn't just fast because of binary data, it's also fast because of HTTP2. In HTTP 1.1, if you want to send parallel requests, you often need multiple open TCP connections. That's expensive. HTTP2 introduces multiplexing. We can send 100 different requests over a single TCP connection at the same time. It also compresses headers. If you're sending the same auth token over and over, HTTP2 optimizes that data usage. A REST is strictly request response. You ask, the server answers. But what if you want a live feed of stock prices? In REST, you have to poll. In gRPC, we have streaming natively. Server streaming lets the server keep talking after one request. Bidirectional streaming allows for true real-time communication, like a phone call, where both parties talk over each other. This is a game changer for latency-sensitive applications. Implementation in gRPC is different. You start with the .proto file. You define your greeting service. Then you run the protoc compiler. This is the cool part. It writes the code for you. It generates the client library and server interface. You don't write HTTP request code manually, you just call the generated method. In the server code, you just fill in the blank function say hello with your logic. The framework handles the rest. Now look at REST equivalent in Node.js. It's more manual. We define routes like /API/items. We have to explicitly handle the request body and decide the HTTP status code to return. It's flexible. We can return whatever JSON we want, but that flexibility means we can also make mistakes. There's no compiler enforcing that our JSON matches what the client expects unless we add extra tools like TypeScript or Zord. Is gRPC actually faster? The answer is yes. Because binary data is smaller, it moves over the network faster. Because computers parse binary faster than they parse text JSON, it uses less CPU. If you have a microservice architecture with thousands of internal calls per second, gRPC can cut your costs and latency dramatically. You cannot easily call gRPC from a web browser. Browsers love JSON and REST. To use gRPC in front-end app, you usually need to write a proxy like gRPC web. Also, debugging is harder. If you inspect a REST network call, you see the JSON. If you inspect gRPC, you see unreadable binary garbage. You need special tools to decode it. Because gRPC keeps the TCP connection open, a standard load balancer might send all the traffic from one client to just one server, even if you have 10 servers running. REST doesn't have this problem because connections cycle frequently. To scale gRPC, you need smarter load balancers that can look inside the HTTP2 stream, or you need to move load balancing logic into the client. So, which one should you pick? If you're building a public API for other developers or web app frontend, stick to REST. It's universal, easy, and caches well. But if you're building the backend internal communication between 50 different microservices, or you need real-time streaming, gRPC is the superior choice. It's strictly typed, hyper efficient, and generates its own code. Hey, if this video helped you understand this topic, don't forget to like and subscribe. You can also drop your suggestions down in the comments about the improvements and the topics you would like me to cover next. Till then, thanks for watching, and I will see you in the next one. Peace.